Welcome back. Today we've got in the workshop here a welder that needs repairs. This is a Cigweld Transarc easy welder. It's an old transformer type one from around the late 70s, early 80s, but they made these welders for many years. It was made in Australia when we used to still manufacture stuff by Commonwealth Industrial Gases, which is CIG. CIG as a brand is now Cigweld. They still exist, but it's a name only. ESAB owns them, the last I heard. These old welders though were made in Australia. They are actually quite good welders. There's thousands and thousands and thousands of these on the market. A lot of people don't use them anymore because everyone thinks they need the latest greatest inverter. We actually use a lot of old transformer welders here in the workshop and when we go out on site. The main reason we do is they don't play up. There's very little to go wrong with them. I'll show you inside the cover in a moment. This one's in for repair. Funnily enough, it's the second one I've had in the workshop here in the last couple of weeks. We've got a bigger one than this. This is a 140 amp. We've got a Transarc 230 as well. That's a two-phase welder. Now, before any electricians or anything start getting on to me about this crap, it's a two-phase welder. If you don't understand what two-phase means, you know, go and learn. This one's a single phase, 15 amp single phase. Can only be wired as single phase. But there were ones that looked exactly like this that could be supplied as three-phase welders. This one also is marketed as the easy welder. It only has the work terminal and the electrode terminal. There is another version of this, sometimes marketed as a tradesman, a Transarc tradesman, but I have seen them marketed as easy welders that have the third terminal in the middle here for when you're using low hydrogen rods, something like 16 TCs or similar to that. This one's 40 to 140. The two main problems it's got today are it needs a new 230 volt plug on it because that one up there is stuffed, and the amp range here is jammed. So when we move the choke, this is a choke type welder, loosen this and pull the choke in or out of the transformer core, and at the same time this gauge should move up and down, and at the minute it gets up to about 60 and then it gets stuck even when the choke's right the way out. I've done these before. The chances are the little slide mechanism in there is stuck. I don't think the spring's broken because I can hear it, but if the spring's broken we'll just put a new spring on it and that just makes it work up and down. They're very simple in here. One other thing, we're in Australia. We're not supposed to do this work. No one is. I don't want to hear from electricians, and particularly not apprentice electricians, telling me that I'm not allowed to go in here and I'm going to get killed and all the rest of it. I'm not interested. Go tell someone else. I don't care. It's very simple. It's just a straight transformer. There's three connections: live, neutral and earth. One thing I will show you inside, if you want to do this yourself, the onus is on you, not on me, is to double make sure that all the earth connections inside are connected where they need to be, because the frame of the transformer is earthed, but also this scale is earthed. Separately joins back to the main earth terminal inside the welder. We'll take the cover off and we'll come back. Okay, so now we've got the covers off the welder. We see here, this is our main earth coming in from our power supply. Earth in the frame and the transformer core here. We've got our live and our neutral in the terminal block over here. And then this set of windings here taps into there. It's just two of the taps joined together, part of the windings. So we only have our live and our neutral on this side to worry about. We don't touch these. These are the primary windings of the transformer coil. Down in here we have our choke bar and a nylon bush that takes it out through the front cover. Over here, this assembly here, I know it's a bit hard to see, this assembly here is part of the gauge for the amp scale. This is the spring I referred to, just goes down and attaches behind there. Now all that was wrong with this, I've already lubed this one up. This is a piece of spring steel, a very, very thin strip of spring steel, and as the choke goes out, this spring pulls that back. As the choke goes in, the choke actually pushes it the other way, and it just goes around that curve, around this curve, and slides backwards and forwards in a little track there. So all we did was put some dry lubricant in under that. We undone the spring, took this out, wiped some dry lubricant onto that piece of spring steel, hooked the spring back up, and it works perfectly now. We will clean the choke rod down in here. It's just a bit grimy. It's very dirty down in here. There's a lot of dust and stuff. Sorry you can't see that. So down in here under the transformer, this is just an open cavity because these transformers aren't fan cooled. They just rely on convection, so sucking cold air in as the hot air rises and comes out the vents on the top when the cover's on it. So just a tip, guys, in under here there's always dust and cobwebs and stuff like that. I'll give this one a quick sweep out, but I'll take it out and blow it out later. That is what can cause one of these to catch on fire. It's pretty rare, but it can happen. So just periodically whip the bolts out, take the cover off, even if you lift the cover up a couple of inches and blow some compressed air out through under there and just clean the cobwebs and stuff out. It's a good idea because all these machines are getting older, even though they're still very serviceable, just to have a once over of the windings of the insulation on the windings, and just check that nothing looks scorched or there's no tracks across the windings or anything else. On the other side, the windings are very wide. They're made out of aluminium in this one. Now, in these welders, at the amps that they can do, aluminium or copper, it makes no real difference. Some of the older ones of these had copper windings. This one's got aluminium. You can't really tell the difference when you're welding at the amperage that they're made for. Down here you'll see the aluminium strip comes along there where the pointer is and goes to your electrode terminal. There's another one comes off and goes to the earth work terminal over there. Now the other earth that I mentioned for the input side, you'll see there's another green and yellow wire comes down. It's a bit hard to see. This green and yellow wire, that's better, comes down and goes onto a terminal here. The terminal is down in there, but that bracket is all the one bracket, and it earths this strip, and it also helps to earth the parts that are connected to the front cover, just in case something goes a bit awry. So always, because of this hanging down low, always when you've got the cover off, if you're going to do something like this, check that that earth is also connected where it should be, that this wire hasn't been broken or hasn't been taken off altogether. It is very important. Up here, these connections are okay. So what we'll do, this plug is a bit iffy. It's got, the nut won't go on it anymore, the poly nut that goes on it won't go on it anymore. But about back here there's actually a problem in the cable inside. I can feel that the outside insulation's broken. So what we'll do is we'll snip it off back here somewhere. We'll put a new 3-pin plug on it. We'll disconnect it up here out of the terminal block, and we'll run the insulation test just on the power supply cord. If at all checks out and everything's good, we'll do that at probably 750 volts. If all that's good, we'll just reconnect these, keep the new plug on the end, give her a blowout, put it back together, and the job's a good one. Thanks for watching.